Hello, this is Janset. Today I will present the automated theory, context-free grammar into Chomsky normal form parsing project, library book search operation. The purpose of this project is to provide users with a convenient and efficient way to find the location of the books within the library. As a start, I created my context-free grammar by adding the lexicons based on the sentence I want to use in this project. I listed 16 valid and 4 invalid sentences I want to use for this project. Here. As a second step, I converted the context-free grammar into Chomsky normal form. To do that, there are 3 rules need to be followed. The first rule is epsilon only can be with the start symbol. Since I don't have any epsilon, I don't need to implement this rule. The second rule is convert to binary form, which means right-hand side of the rows can have only 2 non-terminals. Most of them is good for this rule, but I have 1 and 2 of them need to be converted. In order to do that, I created another variable here and assigned 2 of them in this variable and add that variable to there. And I did same thing here too. And the third rule is simplify mixed rules, which means make each rule only have terminals or non-terminals. As you see, terminals and non-terminals. So I implemented this rule too. CKY tables. I created CKY tables for each sentences. I start with the valid sentence. As you see, I created the table based on the length of the sentence. For this sentence, I have 6 words. I added the indexes starting from 0. Here and here. This way, when I say 0 to 1, I will point the first word. 1 to 2 will point the second word. 5 to 6 will point the 6th word. And then I use the bottom-up approach, starting from this side. This one, the first one is list. It's a verb, and grammar gives 3 different options for that one, and I added that. I did all calculations on the left side. And when I came here, it is this one, the determinant. I added 1 to determinant. And the third one, 0 to 2. In order to get the 0 to 2, I need to get 0 to 1 and 1 to 2. 0 to 1 has 3 options. 1 to 2 has determinant. When I check my grammar, I don't have any determinant VP or determinant verb or determinant S, which means this one is empty. I added that and moved to the next column. Here, books, non-nominal. I added that. The next column, here, 1, 3. To get 1, 3, I need to do 1, 2 and 2, 3. 1, 2 is determinant. 2, 3 is non-nominal. In my grammar, there is no non-determinant, but I have a nominal determinant, which is MP. I added that and moved to the next step. Just like this, I completed all of them, and calculations are listed here. In order to identify this one is valid sentence, I need to have S at least on the last box here. Since I have an S here, I can say this one is a valid sentence. And I did the same calculation for every other sentences. Here, all other valid sentence tables. Now, invalid sentence. I used an invalid sentence with 5 words and create the table according to that. Again, indexing and starting from there, its determinant here. Title, it's non-nominal here. And for this one, I need to use 0 to 1, 1 to 2. Again, nominal and determinant has MP here, and preposition gets there. Just like that, I completed the difference between valid and invalid sentence table. The last box is, since there is no S, it's an empty box. It should be invalid sentence. here other invalid sentence tables. I created my code with Java using Eclipse. Here is my code. Okay, so another one. Yes, that is invalid, and one more. Books. This was the demonstration for the code, and I add the copy of the parser code using Java here. I also add the snapshots for valid sentences, which 6 of them is here, and 5 more and 5 more, and for the invalid sentences here. This is all for this project presentation. Have a nice day.